Hello all, welcome to the course Fundamentals of Food Process Engineering. So these will be a doubt clearing sessions where we'll solve the assignment problems. So we'll begin with assignment 0. I'm Aditi K. I'm a PMRF teaching assistant and I'll be taking and conducting all the doubt clearing sessions every weekend. So in case of any doubts, you can contact me in this email ID bd18d700@smail.iitm.ac.in. So let's move on to the questions of assignment 0. The first question is the amount of sucrose given is 30 kg and the amount of water given is 70 kg. And the molecular weight of sucrose is given to be 342 gram per gram. So what is the mole fraction of sucrose is the question. So for the answer, the molecular weight of water we already know is 18 gram per gram mole. And in order to calculate a mole fraction of any compound, say in a mixture A and B, so the mole fraction of A will be calculated by moles of A divided by moles of A plus moles of B. So in this case, we need to calculate the mole fraction of sucrose. So A in this case will be sucrose and B will be water. So in order to calculate the mole fraction, we need to first figure out what are the moles of sucrose and water. So moles of sucrose is amount divided by molecular weight. So 30 kg divided by 342 gram per gram mole. And the moles of water is 70 kg divided by 18 gram per gram mole. So when we substitute these values in this equation, we get mole fraction of sucrose is 30 divided by 342, which is moles of sucrose, divided by moles of sucrose plus moles of water, that is 70 by 18. So when we calculate, we get 0.022. So the correct answer to this question is given in option C, which is 0.022. Moving on to question 2, there's a mixing process that is happening where there are two inlet feeds. One is cow beef and the total amount of inlet is XC, where it contains 20% of fat. The other inlet is bull beef that contains 5% of fat. And together these inlet feeds are mixed together to get a mixture with 10% fat. So let us assume that the amount of cow beef and bull beef is XC and XB, and the total amount of mixture or the product that we get is XP. So what is asked is ratio of XC to XP in this question. So we assume that a total of 100 kg is the outlet feed, and since it is only a mixing procedure, there is no other inlet or outlet, so whatever amount we send in is the amount that we take out. So inlet amount is equal to outlet. So XC plus XB, that is the mass of inlet feeds, is equal to the mass of outlet feed. And since again this is only a mixing process, the total amount of fat in these feeds remain constant. So the total amount of fat in the inlet feed should be equal to the total amount of fat in the outlet feed. So for the inlet feed, it has 20% of fat in cow beef and 5% of fat in bull beef. So this can be represented by 20% of XC, that is 0.2 of XC, and plus 5% of XB, that is 0.05 of XB. So this will be your total fat in the inlet feed. So this should be equal to the total fat in the outlet feed, which is 10% of XP. XP in this case we are assuming to be 100 kgs. So it is 0.1 into 100 kgs. So now we have two variables XC and XB, and we have two equations. So we can simultaneously solve these equations to get XC and XB. So if we solve these equations, we get XC is equal to 33.34 kgs and XB to be 66.66 kgs. Now since we require the ratio of XC to XB, we divide XC by XB and we get a value of 1 by 2. So the correct answer to this is 1:2, which is given in option A. Moving on to question 3, this is a drying process where 50 kg of wet protein with 50% moisture is sent inside the dryer per hour, and in order to dry this protein, they are using 10 kg of fuel. So this 10 kg of fuel has a calorific value of 12,500 kilojoule per kg. So 10 kg of fuel is used to heat the wet protein to finally get a dry protein with 10% moisture. So what else is given is the latent heat of evaporation is 2257 kilojoule per kg. And what is asked is the thermal efficiency of the dryer. And we have been asked to ignore the sensible heat. So we need to first calculate how much energy is being utilized in burning this 10 kg of fuel. So that can be calculated by mass of the fuel into its calorific value. Mass of the fuel is 10 kgs and calorific value is 12,500 kilojoule per kg. So total giving the energy of 1,25,000 kilojoules. So this is the total energy being utilized from the fuel. So in order to calculate how much water is being evaporated, that is, where is this energy being utilized, we need to first calculate how much of water is being evaporated. That we can find out by the solid balance. That is, the amount of solid in this entire process remains constant. It is only the water that is getting evaporated. The dry weight remains constant. So in order to calculate the amount of dry weight in this process, we use this formula. 1 minus x1 into m1 equals to 1 minus x2 into m2, where x1 is the inlet moisture content, which is 50%, and x2 is the outlet moisture content, which is 10%. So 1 minus x1 will give you the percentage of dry weight in the inlet field, and 1 minus x2 will give you the percentage of dry weight in the outlet field. So into m1 being the mass of the inlet field and m2 being the mass of the outlet field. So here we already know x1 as 50% and m1 is given as 50 kg per hour. Here m1 is 50 kg and x2 is 10% moisture and m2 we still don't know. We don't know how much amount of protein is coming out from the dryer. So in order to calculate m2, we substitute the values and we get an m2 of 27.78 kgs. So since this is a drying process, there is some amount of water being evaporated, and this you can calculate if you can find out the difference between the M1 and the M2. So as you can see here, you are sending in 50 kg of protein, but what you are getting out is only 27.78 kg of the protein. So the rest of the amount mass should be water that is being evaporated because of the fuel burning and the drying process. So in order to calculate how much water is being evaporated, we calculate M1 minus M2, that is the mass of the wet protein minus the mass of the dry protein. That will give us the total water lost. So 50 kg minus 27.78 kg gives us 22.22 kg of water being lost. So the theoretical heat required to evaporate this much amount of water can be calculated using this equation, provided sensible heat is ignored. So mass of the water evaporated into the latent heat of vaporization. So this is 22.22 kg and latent heat of vaporization we are getting from the problem itself, which is 2257 kilojoule per kg. So totally it accounts to 50,150.54 kilojoules. So this is the theoretical heat required to evaporate 22 kgs of water. So the efficiency of the dryer can be calculated by theoretical heat required by the actual heat utilized by burning of the fuel into 100. So when we substitute the values, we get 40.12%. The theoretical heat required is here and the actual heat required we calculated from the calorific value of the fuel. So this accounts to 40.12%. So the correct answer for this question is option D, which is 40.12%. Moving on to question 4. So this is a cold storage unit where heat removal rate is 25 megajoules per hour, but there's a small heat leakage inside the storage unit, which is 5 megajoules per hour. And the total mass of the apple that is stored inside the cold storage unit is 1000 kgs and the specific heat is 3.5 kilojoule per kg degree Celsius. The initial temperature of the apple is 25 degrees and the final temperature is 5 degrees. So the time required for the process is what we need to calculate. In order to calculate that, we first need to find out what is the net heat removal rate. Since there's a small leakage, we need to find out the net heat removal rate, which is the removal rate minus the leakage rate. That is 25 megajoules per hour minus 5 megajoules per hour, which accounts to 20 megajoules per hour. So the heat that needs to be removed to bring down the temperature from 25 to 5 degrees Celsius can be calculated by mCp delta T, where m is 1000 kgs as given here, Cp is 3.5 kilojoule per kg degree Celsius, and T1 is 25 degrees and T2 is 5 degrees. So total it accounts to 70,000 kilojoules. So the time required can be calculated from the total heat that needs to be removed divided by the heat removal rate. So here in this step you need to make sure that the units are same. Here the net removal rate is in megajoules and this is in kilojoules. So we convert megajoules to kilojoules, that is 20 into 10 power 3 kilojoules per hour, and this will be 70,000 kilojoules. So total when you substitute it, the time comes out to be 3.5 hours. So the correct answer to this question is option A. Moving on to question 5. The pressure given for water is 200 kilopascals. So this can be calculated into pascals as 2 lakhs pascals. So, and we need to find out what is the water head or the height of the liquid to exert this certain amount of pressure. So we already know that the density of the water is 1000 kg per meter cube, and the pressure can be calculated from P equal to rho gh, where rho is the density, g is the acceleration due to gravity, and h is the height of the liquid. So when we substitute the values, 2 lakh pascals equal to 1000 kg per meter cube into 9.8 meter per second square into height of the liquid. So height comes out to be 20.39 meter, which is nothing but the water head. So the correct answer to this question is option A. Moving on to question 6. What is the unit of kinematic viscosity? So we know that kinematic viscosity is equal to dynamic viscosity divided by density. So we need to figure out the units of dynamic viscosity and density. So this, for dynamic viscosity, the units is Pascal second, and for density it is kg per meter cube. So Pascal second, Pascals also we need to convert it into kg meter and second form. So Pascal's pressure is nothing but force per unit area. So Newton per meter square into second divided by kg per meter cube. Again we will simplify Newton into mass into acceleration, that is kg into meter per second square divided by 1 by meter square for pascals into second divided by kg per meter cube. If you further simplify this, you will get meter square per second. So the correct answer to this question is option D. So question 7 is asking about the relationship between kinematic viscosity and dynamic viscosity. That is given by the same formula. Kinematic viscosity is equal to dynamic viscosity divided by density. So the correct answer to this question is option B. Moving on to question 8. We are asked the relationship between different pressures mentioned in the question. So for that we need to first understand what the different pressures are. So just a small definition. So absolute pressure P absolute is the actual pressure given at a certain point, and it is calculated from a reference point also known as the absolute vacuum. So any pressure that is calculated from this reference point will be P absolute, and this will denote the actual pressure at a given position. And atmospheric pressure is the pressure exerted due to the atmosphere. Vacuum pressure is the pressure measured below the atmospheric pressure. So in this case, this is your P absolute, that is measured from the absolute vacuum, but this pressure is below the atmospheric pressure. So this particular is known as vacuum pressure, the pressure below the atmospheric pressure. And the gauge pressure is the pressure relative to the atmospheric pressure as shown in the figure. So P absolute is equal to P atmospheric minus P vacuum. This is visible from the diagram. So P absolute is equal to P atmospheric, that is the total, minus P vacuum. So this is the correct relation, and the answer to this question is option B. In question 9, there are two statements given for which we need to figure out if it is true or false. So the first statement is viscosity of gases increase with temperature, and the second statement is viscosity of liquids decrease with temperature. So in case of gases, the increase in temperature results in increased collision of the gas molecules. So this increased collisions will prevent the flow of the gases, that is, it will increase the resistance to the flow. And the moment there is an increase to the resistance in flow, viscosity of the fluid also increases. So in case of gases, increase in temperature results in increased collisions results in increased resistance, and increased resistance results in increased viscosity. Hence, the statement is true. In case of second statement, that is in liquids, the resistance to flow occurs because of intermolecular interactions happening between the liquid molecules. So when the temperature is increased, the intermolecular attractions also decrease. Any kind of intermolecular attractions decrease, and hence, since the attractions decrease, the resistance to flow also decreases. Hence, viscosity also decreases. Hence, it's opposite in case of liquids. In case of gases, viscosity increases with temperature, and in case of liquids, viscosity decreases with temperature. Hence, both the statements are true, and the correct answer to this question is option A. Moving on to the last question. The volumetric flow rate in a pipe is given as 0.5 meter cube per second. The diameter of the pipe is 0.5 meter. The length of the pipe is 5 meter. The viscosity of the fluid given is 50 pascal second, and the density given is 1000 kg per meter cube. And we are asked to assume a laminar flow, and we are asked what is the pressure drop across the tubes. First, we need to calculate the velocity of the fluid that in the pipe. So, velocity of the fluid in the pipe can be calculated by volumetric flow rate divided by cross-sectional area. Volumetric flow rate Q is given here as 0.5 meter cube per second. Cross-sectional area is that of the pipe, which is given by pi into d square by 4, where d is the diameter of the pipe. So, if you substitute the values, that is Q as 0.5 meter cube per second and diameter as 0.5 meter, we get a value of 2.55 meter per second as the velocity. So in order to calculate the pressure drop, we use Hagen-Poiseuille's equation, where delta P is equal to 32 mu L V d square for a laminar flow. So where mu stands for viscosity of the fluid, L stands for length of the pipe, V stands for velocity in the pipe, and d square stands for diameter of the pipe. So when we substitute the values, mu as 50 pascal second, L as length of the pipe, which is 5 meters, and V as 2.55 meter per second as we calculated here, and d square is 0.5 into 0.5 square, we get a pressure of 81,600 pascals. So the correct answer to this question is option B. So that's all for this assignment. So in case of any doubts, you can either post it in the discussion forum, or you can mail at bt18d700@smail.iitm.ac.in. I will either reply back to you in mail, or we'll take it up in the next online session. Okay, thank you.